So CPCTC, I'm going to write over here what that stands for. It stands for corresponding parts okay, of congruent triangles okay, are congruent. So there's the C, the P, the C, the T, and the C. CPCTC. Okay? So you can see that instead of writing this huge statement, okay, out in our proofs, we're just going to use this acronym here, CPCTC. Okay? And so let's kind of break down exactly what the statement is saying here. So, corresponding parts. Well, we've seen that word corresponding before. Okay, we've seen it, remember we talked about parallel lines crossed by transversal, right? We had those, so for example, I'll draw a little picture here, right? Parallel lines, oh, thank you, yes, I didn't get that one too. Okay, parallel lines crossed by transversal. Remember, for example, that this angle right here and this angle right here, and I'll zoom in on that some because I know it's like really hard to see. Okay. When we had parallel lines crossed by a transversal, we had this angle here, this angle here. They were corresponding. And what made them corresponding? Well, because they're like in matching positions, right? This one's kind of like the top left angle in this little cluster of 4, and this is the top left angle here in the kind of cluster of 4. Okay? So they're corresponding, right? Matching. And so when we say corresponding parts, we're saying matching parts. Okay? Kind of like what Courtney did earlier today when she saw that one part of the triangle matched to another part and was able to say that those two are going to be equal in length. Okay? She found corresponding or matching parts. Okay? And how did she know that they were going to be equal in length? Well, because they were matching parts or corresponding parts of congruent triangles. Okay? So Courtney had seen that we already proved the two triangles congruent, so when she matched those two parts together, she knew they also had to be congruent. So without even knowing it, Courtney was using CPCTC. She knew that matching or corresponding parts of congruent triangles had to also be equal. And that's what she used today. That's what she just did without knowing it. Okay, so this is something we kind of like know has to be true. If we prove two triangles congruent, that means their matching parts must be also congruent. All right, we'll get into one of those proofs here in a little bit. Okay, that's going to be our third proof down here. Is going to be a CPCTC proof. So we'll focus on getting these three done, and then I'll kind of refresh our memory back there about CPCTC. Okay, we'll go into right here. All right, so let's look at this first one right now. And again, two triangles here are congruent. All right. I see right angles here in our triangle. So like right away that I see these right angles, I'm thinking this could be hypotenuse leg, right? Because the hypotenuse and a leg, a hypotenuse only occurs in what kind of triangles? Right triangles. So if you have right triangles, you may, I'll be very careful about that, you may use hypotenuse leg. You don't always use hypotenuse leg. Remember the homework we just had, right? We had right angles. So that means we had hypotenuses in there, right? WT was a hypotenuse, RU was a hypotenuse, but we didn't use hypotenuse leg. It didn't end up being hypotenuse leg. It ended up being angle side. So just because you see right angles doesn't necessarily mean that's true, but here in this case it will be. It's going to be one, okay? So let's kind of kick things off here. So MPQ and MNQ are 90 degrees. Well, there's MPQ. It's already marked as 90 degrees. MNQ also already marked as 90 degrees. We're also told that MN is congruent to PQ. So here's MN. Okay, we'll mark that congruent to PQ. All right, so there's kind of our starting point. All right, so let's see here. Antoinette, can you tell me, are there any other pieces of this triangle that we know will be congruent based on the picture? We've already kind of like marked our congruences from the given information. Can you see anything else that will be congruent between these two triangles based on the picture? Yeah, very good. Yeah, MQ is congruent to MQ. Okay, it's going to be congruent to itself there. All right. So perfect. So we have three pieces of information here. So let's get listing. So step one. Okay, we're going to list out that MPQ is congruent to angle MNQ. Okay. And how do we know that's true? Alex, how do we know that these two angles were equal? Because it's given. You got it.
But we have to like,
They're equal to each other, and it's equal to 90 degrees. So it's like, not only we know they're not only equal to each other, but we also know what they equal. It's 90 degrees. But we can say they're congruent because...
You don't have to write it right.
No, you don't have to. We just need to say they're congruent. If you write the 90, though, it's not wrong. It's just extra information. Okay?
Wait, I can't see you right, so...
You can't see... Oh, I'm sorry. I zoomed in too far. Thank you for saying something, Tristan. Okay, very good. Thank you, Tristan. All right, Donovan, number 2. What's another congruence that we can write here? We already used this piece of information. What else can we write? Okay, we did. I wrote that. MPQ is congruent to MX. So we did that one already. So what else could I write that's congruent here? Okay, so MNQ, right? We have that one there too. Those two are congruent. So again, what other piece? We already said that MPQ is congruent to MNQ. What else is there in the given information, Donovan? Say again, sorry? Look at the given information is what I'm saying. There's another congruence right there in the given information. There you go, yeah, MN is congruent to PQ. Very good, okay? So there we go. So we mark down. And, Donovan, how do we know they're congruent? Why? It's given. Yep, it was given to us that they were congruent. Okay? Great.
I have a question.
Yes.
Okay, so those two are given to us. Can we just put them, like, as one?
Yes.
Still?
Yes, if you want to put angle MPQ is congruent to angle MNQ, comma, MN is congruent to PQ, that can be all one step because they have the same reason. Yes. Yeah, I know. Yes, it's that easy. Yes. Yes. Yes.
Okay, so yesterday you said that they have to be in a certain order or else it's wrong. So how would you how do you know that you have to have them in the right order? Because what if you get them messed up?
Okay, so, well, first of all, if you're writing from the given information, it will be in the right order. You don't have to worry about that then. Okay? It's when you're pulling information out of the picture that you then want to be careful with how you name things, because you could name things incorrectly. So let me just go back to an example from the homework, okay? So for example here, at this problem, I had to look at the picture to show that these two angles were going to be equal because they're vertical. Okay? So naming the two angles correctly, though, that's where we have to be careful, right? I can't just pick any 3 letters here to name this angle. I have to be very careful. C is the point of that angle, so C has to be the middle letter of the angle name. And then from that point, it doesn't matter. I could say ACB or I could say BCA, but either way, C has to be in the middle to name it. And then same thing over here. If I want to name this angle here, again, C is the point, so C is going to be the middle letter, but now I'm looking at ECD or DCE. Okay? But you can't just use these 3 letters any way you want. For example, if I just said CED, well, E is the middle letter. When I say CED, E is the middle letter, so that means the point of my angle would be up here. Well, that's not the angle I would be talking about. I want to talk about this one. You see what I'm saying? So use the point of the angle to help you figure out what the middle letter's got to be, and then the other 2 letters are just either whatever order you want there from the sides. Okay? All right. But these, they're given to us in order. All right. Number 3, let's go to Debbie. Debbie, what's another congruence we can list here? Yep, MQ is congruent to MQ, or QM is congruent to QM, or MQ is congruent to QM, or QM is congruent to MQ. You got, a couple different ways you can write it there. And what's the reason for that, Debbie? Reflexive property. You got it. Okay. So, now we're going to we have our 3 congruences there, so we're going to write triangle MPQ is congruent to triangle QNM. All right, and let's see here. What is our reason? Let's see. Well, if I look at my picture, all right, I've got an angle, and then a side, and then a side. Right? It goes angle, side, side. Okay, so we're going to write angle, side. Wait a minute. Mr. Wade told us that angle, side, side is not a congruent statement. So we should never write on our paper angle side side, even if we don't like Mr. Widmeyer and we want to say bad words to him, okay? We don't do that. No angle side side. It's not a thing. This is hypotenuse leg. Okay? Yeah. Yeah. I know, it's early in the morning.
Wait, what's HL?
Hypotenuse leg. Okay, so why is it hypotenuse leg here? We have right triangles, right? And in right triangles, we do have a hypotenuse. Hypotenuse is the opposite side from the right angle. So notice here, the hypotenuse is congruent to the other hypotenuse, right? This is the hypotenuse for this triangle, and then this is also the hypotenuse for the other right triangle. How do I know? They're both opposite the right angles there. Okay, and then the leg. The legs of a right triangle are the other two sides. So here's a leg congruent to this leg. Okay, we didn't know anything about PM or NQ. They may be congruent, they may not be. We know that these two legs are congruent. So a hypotenuse and the leg are congruent, and so it's congruent by hypotenuse leg. Do not write angle side side. Do not write angle side side. Do not write angle side side. It's wrong every single time.
So while we're on the test, right?
You're on a test. Gotcha.
And then, so there's like some of my class where we don't know that when it's doing this angle like that, like all 3 or 4, same. And then someone put, angle side.
Angle side angle. So that would still be wrong, obviously, in this case, because there's only one pair of angles we know are congruent. So angle side angle, we don't have a second angle here marked congruent. So we can't say.
So you would mark it wrong.
Now, granted, let's see here. Let's see if we can... Oh, yeah, no. So, yeah, it would mark it wrong. This one has to be hypotenuse leg. It has to be. There's no other congruence that would work here for this information that we've been given.
I know that was a stupid question, but like
No.
I'm just saying, like if you had like all the information correct and then you just like have that one part wrong.
You would miss that piece. You'd have all the other points from getting the steps correct. Like, I don't say, if you come to the wrong conclusion here about what the congruence is, I'm not going to say the whole thing's wrong. You lose 1 point for that one, but you'll get, 6, 7 other points. So 7 points, you just miss the 8th point. You know what I mean? Okay, next one. Here we go. So let's see here. For this next one, we've got, again, 2 triangles. We got some given information here. So let's go to... Oh, someone hits here. Nope. Try again. All right, Colin S. So, Colin, what does this little symbol here mean between KL and JM? What's that symbol mean? Okay, well, what does it look like? If you look here, it looks like an upside down... No animal noises, thank you, Alex. Okay. This little symbol right here looks like an upside down capital T. If you look though, it's 2 segments, 2 little segments that are meeting at a right angle. So that means this segment KL is what to JM? Yeah, perpendicular is the word you want to use there. Perpendicular. Okay. That means this angle KL, or this segment KL. Listen up, please, folks. Eli, face forward, please. No talking to Kwanye. Kwanye, listen up, please. Okay? Thank you. KL is perpendicular to JM, which means they make right angles. So this is a right angle, and this is a right angle, too. I'm sorry, it's out of the picture. There you go, sorry. Those 2 angles are right angles. Okay? Is there anything else we can mark congruent here, Colin, based off of our information that we're given? We kind of mark this in our picture. What else can we mark in our picture there from the given information? Okay, so JK is congruent to segment KM. Okay? Very good. So that's congruent. And then can you see any other congruence in this picture here that we could mark? We already used up our given information. In the picture, though, is there something else we can say is going to be congruent about this triangle and this triangle here? Is there anything else we can say is congruent? No, 1 second. Not sure? All right, let's go to someone else. Let's say, Donovan already called on you. I won't bother you again there. Blake, is there anything else we can mark congruent here in this picture? KL is congruent to KL. You see, and I know it might have been obvious to see that, but the idea is that this side is shared by this triangle over here, and this side is also shared by this triangle. So it's going to be congruent to itself. They are also kind of matching to themselves. Yep.
If we would have said it, because I have said like KL, like
Yeah, and we kind of like, we're going to say that in our steps over here. I mean, they're both marked as 90-degree angles, so yeah, you could say they're congruent then too. Yeah, because of that. All right, so let's start writing some things down then, okay? So first congruence, we'll go ahead and just write down the congruence that were given in the given. Okay, that was kind of redundant. Anyway. Write down our given congruence. JK is congruent to KM. And our reason for that would be what there, Jason? Oh, you can't see it, sorry. Thank you. I need to like adjust here. Yeah, it's given. Thank you, Jason. Okay. All right. All right, so Corey, what's another congruence again marked down here? And the proof. Congruent. So you said KL is congruent to what? JM? Perpendicular. Oh, I see what you're saying. Okay, I'm sorry, I'm going the wrong. Okay, I see what you're saying. So we got to name the angles then. So we're going to say angle. So how would we name this angle right here? JLK, that's a great way to say it. JLK is going to be congruent to what other angle? MLK. Martin Luther King. There you go. Okay. And they're congruent because, why do we know that? KL is perpendicular to JM. We can't say it bisects, but I hear it. Yeah, it's perpendicular to. Okay, that was a given. Okay. Great. That's that. And then, yep. Rob, you want to do the last one? KL is congruent to KL. Yeah, there you go. KL is congruent to KL. Okay, and so why is that true, Robbie? Reflexive property. Very good, sir. Okay, and you can abbreviate too. I wrote the whole word reflexive property. You can just say reflexive prop. All right, so we've got 1, 2, 3 congruences. So let's see if we can prove these triangles congruent. We're going to say triangle JLK, as written there. JLK is congruent to triangle MLK. Okay, and so again, we'll look at our pieces of information here. So it goes angle, side, side. So we're going to write ASS. No, we're not going to write ASS.
Dang it. That made sense, but okay.
Right, because angle side side is not a congruence, but because these two angles are right angles,
Oh, wouldn't it be on CPCTC?
Nope, this is hypotenuse leg still. Hypotenuse leg. We're going to get to that. We're going to get to CPCTC. Next proof. No, thank you for volunteering. But it's hypotenuse leg, okay? There is no angle side side congruence. If you write down angle side side, okay, that is wrong. I guarantee it. There is no angle side side congruence. And it's not just because math teachers don't want you to write a bad word on your paper. That is not enough information to prove the triangle is congruent. Okay?
Give me a bad word.
A donkey. Okay? All right. Moving on. Okay. Last one here. Here I want to highlight again. What's different about this proof? What's unique about this proof here than some of the other stuff? Debbie?
You're not trying to find the triangle.
Right, if you look here, the thing we're trying to prove is different than all the other proofs we've done this far. The thing we're trying to prove is different than all the other things we've been trying to prove thus far. In the last proof here, it was 2 triangles congruent. In the last proof here, proved 2 triangles congruent. In the homework, prove 2 triangles congruent. Prove 2 triangles congruent. Prove 2 triangles congruent. Here, prove 2 triangles congruent.
For this one?
Yeah.
It's like kind of guessing that it would be the other one because it's not like the right triangle.
Right, so yeah, so it's going to be a CPCTC. Exactly right, okay? And that's good powers of deduction there. But another reason why we can tell it's CPCTC, just not just because there's no right angles, right, so we know it can't be a hypotenuse leg. Another reason why we know it's going to be CPCTC is because we're trying to prove a part, right? AB is a part of one of these triangles. AB is a part of one, and CD is a part of another. Okay, and in fact, it looks like AB and CD match, that they're corresponding. And so our final argument is going to be that this corresponding part to this part are going to be congruent because the two triangles are congruent. Okay? So in other words, our steps are going to be, we're going to prove the two triangles are congruent, and then because we know the two triangles are congruent, then we can say that this part will be congruent to this part. Okay? That's the idea. So let's take a look at this here. It's just one extra step, basically, than what we've been doing before. So AB is parallel to CD. Okay? AB, parallel to CD. We'll mark that in just like that. We also know that BC is parallel to DA. Now, I already used a single arrow for AB and CD, so to show that BC is parallel to DA, what should I do there? Yeah, two arrows. Okay? Just to show it's a double. It's that those are matching. Okay. That given information gave us no congruences. Debbie?
What is C and A, the angle C and A?
Okay, why do you want to say that?
Well, because the line is supposed to be parallel.
Correct. So A and C, they do look like they will be congruent, but they're not on the same transversal. You see, C is like, so we kind of think about it this way, right? We have a parallel line here, right? So these two parallel lines. Our transversal, there is a transversal crossing that right here, but C and A are on different kind of transversals. Yes, the transversals are parallel, but they're not the same transversal. So we actually can't say that A and C are going to be congruent here, but there are other congruent angles we could say. Okay, so yeah, B and D, but now we got to be careful, because at B, I see 1, 2, and then a third bigger angle there, and at D, I see 1, 2, and then a third big angle right here. So we can't just name B and D, we have to use the 3-letter names here. So, let's see here, so BDC, so okay, so this angle right here, BDC, I'm going to go ahead and write this down. Angle BDC will be congruent to what other angle? So we want this angle right here, right? How do we name that angle? DBA or ABD. So either way you want to name it there. Okay, so yeah, those two angles will be congruent. Yeah, angle DAB if you want to do that. Well, we can't do DAB, that's right, because it doesn't work actually. Okay? And why are those two angles congruent? What relationship is that? They're on alternate sides of the transversal, right? One's below this transversal here, one's above it, and they're in between the parallel lines. So they're alternate interior angles, okay, are congruent. So again, we're reviewing those parallel line angle relationship properties. Okay, so these two angles are congruent because they're alternate interior angles. Okay, and Debbie, do you see the difference here? We have parallel line, well, actually we're using these parallel lines. We're using this line parallel to this line, and it's on the same transversal. We're using this transversal, so they're both part of that same one. So that's why we can say they are alternate interior. You see the difference there? I know it's subtle, but that's the idea.
So the reason why we did that is because the only thing that can
How do we know that's the case? Anytime you have parallel lines, you're going to want to look for those special parallel line relationships. Alternate interior angles, alternate exterior angles, maybe, corresponding angles, maybe. The big one we always tend to see is this alternate interior angles. Correct. But then because we have these lines are parallel, okay, and crossed by a transversal, and so that makes these two angles congruent. But we also have these two lines parallel and crossed by that same transversal. So what other two angles will be congruent? I'm going to pick someone here. Let's go to someone I haven't talked to yet. Oh, I keep picking up. Okay, so Piper. What other two angles here will be congruent? DBC. BDA or ADB. Yep, right. This one right here. Okay. So because we have these two parallel lines crossed by these two lines are parallel crossed by transversal, then these alternate interior angles will also be congruent. So she's exactly right. Very good, Piper. Angle CBD will be congruent to angle BDA. And again, because alternate interior angles are congruent. Okay, I'm just using the congruent symbol there. All right, cool. Very good. There's one more congruence we need. Gabe, can you tell me what's another congruence in this picture we didn't list yet? We use this piece of information. We use this piece of information. What else is going to be congruent in this picture between these two triangles? BD will be congruent to BD. That's right. BD is congruent to BD. BD. Okay, so I'll mark that in the picture there. And what's the property for that? Reflexive property. Reflexive property. Okay. All right. So now we have Mitch.
So I know we're trying to prove like AB is congruent to CB.
Mm-hmm.
But if like both sides are like parallel, doesn't that already make them like equal?
Essentially, yes, but it's also like to argue that with the tools that we have right now, the reasoning, what would our reason be for that? I mean, we like intuitively you sense that that's true, but we want to come up with like hard facts that we know are going to be true, and then use that to support our answer. So we're almost done, though. I mean, so we're almost there. But you're right. Yes, yes, you're right. It's going to be that way. But then how would you prove that? We don't have like a theorem or something like that, like what you're trying to say. But what we do have is that now we can name these two triangles to be congruent. So I'm going to name the first triangle, this bottom one here, triangle ABD. That first triangle you can name however you want, but now when we go to name the second one, we have to be careful about how we're going to name the other triangle. I said A to B to D. So since I started with A in this triangle, what do I have to start with in this triangle over here? C. And then I went from A to B, so from C I have to go which way? D, and then up to B. Okay? And then what makes those two triangles congruent? Nope. What makes the two triangles congruent? We're going to get to CPCTC. What congruence is here, though? It's angle, side angle. Okay? How do you tell that? So let's look at the picture here. Can you see it okay there, Kwanye?
Yeah.
Okay. So we have an angle, a side, and an angle in one triangle congruent to another angle, side, and angle, and the other triangle. So you see how the side is between the two congruent angles? So it's angle, side, angle. Okay? Now, you might be thinking to yourself, Mr. Wade, you told us that this is a CPCTC proof, yet here we are using angle, side, angle. What's the deal? All right? Well, because, here's the thing. Our ultimate goal here is not to prove the two triangles congruent. We want to prove that these two pieces are congruent. However, now we've just shown the two triangles are congruent. Well, look at this. AB, first two letters. CD, first two letters. Will AB be congruent to CD? Yes, they have to be congruent. AB, now that we've shown the two triangles are congruent, their matching parts, that is in this case, AB and CD, must be congruent as well. Why? Because corresponding parts, matching parts, of congruent triangles, we prove them congruent, are also congruent. CPCTC. Okay? That's the idea there. To use CPCTC, we first have to prove the triangles are congruent. Once we prove that the triangles are congruent, the T is the C, triangles are congruent, then we know that the corresponding parts of those triangles are also congruent. Congruent triangles are congruent. Okay? So corresponding parts, AB and CD correspond, right? AB and CD, AB is the first two letters, CD is the first two letters, are congruent. Okay? So we could also use CPCTC at this point to prove that angle C and angle A are congruent. okay, without you know, the previous information. Now they know the two triangles are congruent, we know all their parts will be equal. And that's the idea there. Okay? Questions on any of that? All right, so I got 3 on the back for you there to try. All right? If you look at the top one, you're trying to prove an angle congruent to an angle, so guess what? It's going to end up being a CPCTC. The second one, angle congruent to an angle, so it will be CPCTC. And the last one, you're proving two triangles congruent, so you can kind of guess that one's going to be a hypotenuse leg. Yeah, right. Very good, Kwanye, because, again, we're just proving the triangle's congruent, okay? So for all 3, you still need to prove the triangle's congruent. For these 2, you could use side, angle, angle, side, whatever, but then the last step is going to be proving those parts congruent, okay?
Why are you doing this?
Why am I doing this to you guys? Because